Okay, so we've had a lot of questions come in through email and in our class office hours Zoom about, I think it's distance learning opportunity number 12 and some of the questions on our Delta Math homework. So I'm just going to go ahead and kind of do a couple of these problems here and post this on our YouTube channel just so everybody has a chance, even if they're not joining the Zoom or whatever. Because remember, you do need to get full credit on your homework in order to reach 100% on your homework to get full credit or any credit. It's kind of 1 or 0. So if it's a 90% finished, that's a 0. So we want everybody to get there. Okay, linear system, word problems, movie theater. So there's a lot of problems that, they're really the same, but the numbers are different, the names are different of our friends here going to the movies. So let's kind of look at this. Natalie and Nora go to the movie theater and purchase refreshments for their friends. Natalie spends a total of $166.50 on 6 bags of popcorn and 14 drinks. So, well, let's keep reading. Nora spends $25.25 on 1 bag of popcorn and 2 drinks. Write a system of equations that can be used to find the price of 1 bag of popcorn and the price of 1 drink. So remember the question here at the end where it says, right here, the question, what it's asking me, use the equations to determine and state the price of a drink to the nearest cent, right? These are the variables. It's telling me what the variables are, right? So one of my variables is going to be D for drink, or we could use X, right? And the other one is the price of, the price of a drink, and the other one is the price of popcorn. So we'll call popcorn P and drink D. We could call them X and Y or whatever, it doesn't really matter. So we'll go up here in our first equation, right? Our first person, Natalie, it tells us she buys 6 popcorns and 14 drinks for a total of $166.50. And Nora, she buys 1 bag of popcorn, so 1P, and 2 drinks for a total of $25.25. So these are my 2 equations. Let's highlight them. These are the 2 equations, right, that I'm going to be able to use to find the answer. So I'm going to go ahead and write them down here so they're a little bit closer together. So 6P plus 14D was 166.50, and 1P plus 2D was 25.25. So those are my 2 equations. I think what's probably going to be our best method to solve here is going to be elimination. So we could eliminate whatever we want. This is asking me to find the price of a drink. So solve for D. So if I want to solve for D, I'm probably better off trying to get rid of the P's, right? Because then it'll leave the D by itself. I could eliminate the D's and get the P, but then I got to plug it back in, so it's just extra work. So I'm going to go ahead and I'm going to multiply this whole equation, right? I want this to be this number right here to be a -6, so that when I add them together, I'm going to add these equations together, I want the P's to go away. So I got to multiply that by -6, and I got to do it all the way through. So my top equation, let's clean that up a little bit. My top equation is going to be 6P plus 14D equals 166.50. So nothing's changed there. But this one, after I multiply by -6, I'm going to have -6P minus 12D, right? -6 times 2. And then 6 times 25.25. So that's going to be, and it's negative. So negative, that's $150 plus $1.50. So negative 151.50. And now when I add these together, that's a 0. That's nice. 14 minus 12 is 2D. And 166.50 minus 151.50. The 50 cents cancel out, and I'm left with just $15. So 2 drinks is $15. divide by 2, one drink would be $7.50. Okay, so there's one of our movie problems. Let's kind of scroll down to this next set here. System of equations from context. These are actually probably the ones I got the most questions about. These are a little bit trickier because if I think about my movie problem, right, I had two equations and they were fairly easy to write because they just followed the sentence, and they were both the same format, right? Some number of popcorns plus some number of drinks equals the total cost, and you just had two different cases. So the numbers were different, but the equations looked the same. These are going to be a little bit different. So one of them is going to be like that, but one of them is going to relate the variables to each other instead of to the total. So let's kind of read our sentence here. So Maya is working 2 summer jobs, making $7 per hour babysitting and $11 per hour landscaping. Last week, Maya earned $96 total and worked 3 times as many hours babysitting as she worked landscaping. Determine the number of hours Maya worked babysitting and the number of hours she worked landscaping. So remember the question, it asked me to find the hours worked babysitting and to find the number of hours worked landscaping. So those are the two things it asks me for. Those are the two variables, right? So this time we'll just use x. So x would be the number of hours babysitting. And y would be the number of hours landscaping. So I have to determine what my variables are. Now I'm going to look and see how I can use those two variables to write an equation. So I know with her pay, she worked 7 hours babysitting and she made $7 per hour babysitting, and she earned $11 per hour landscaping for a total of 96. So I can use that to write an equation. $7 times the number of hours babysitting plus 11 times the number of hours landscaping was 96. But we need another equation, right? So that's going to come somewhere from here. She worked 3 times as many hours babysitting as landscaping. So we have to write another equation. This is where it gets tricky because a lot of people are going to want to write 3 times as many hours babysitting. So they're going to want to write 3 times hours babysitting was x equals y, right? That's tempting, but that's actually not what we want to do, right? So these are kind of tough. So what I do is I kind of write an equation. Let's x equals y, right? Let's say the number of hours, that would be the equation if the number of hours was equal, right? But it's not. We know that she worked 3 times as many hours babysitting as landscaping. So the number of hours landscaping, you have to take the number of hours babysitting. Oops, sorry, I just did exactly what I said not to do. 3 times as many hours. All right, so if I think about this, which side the 3 should go on? So here we know she worked 3 times as many hours babysitting. So if x is 3, then y is 1, right? And that makes sense here. If the x is 3, then the y has to be 1. If I did it the other way, it wouldn't work. So that's my, right? If I wrote it this way, right? I know if the x is 1, the x is 3 and the y is 1, I get 9 equals 1. That doesn't work, right? So I have to make sure I have that correct. So now I have my two equations. And kind of scroll down here. And I can use substitution. So x equals 3y. So where I see an x in the equation, I'm going to plug it in. Right, so my new equation would be 7, and now x is 3y, plus 11y equals 96. So 21y plus, whoops, I got ahead of myself there, plus 11y equals 96. 32y is 96. So y equals 3. Now I need to take that and plug it into this equation. So I know x equals 3y and the y is 3. So x equals 9. So kind of my final answer here, if I want to, depending on how it asks me to type it in, x equals 9. So that means she worked 9 hours babysitting, and y equals 3, right? And y is the number of hours landscaping. So 3 hours landscape. That's my final answer. And then one more question from the same assignment. It wasn't on systems of equations, but it was a review of how to write the equation of a line from 2 points. It's in the same DLO number 12. So remember our equation for a line, y equals mx plus b. And both of these points are on the line, so I can use either one of these points. I'll just pick this one because it doesn't have any negatives. I like that, as the x and the y. So I know what the x and the y are, but I don't know the m or the b, right? So I have to find it. I can't find the b super easy from these, but I can find the m pretty easily, right? So we went like this. We made a little table, and we asked ourselves, how did the y change? Right? So from -8 to 6, that's going to go up, so positive 14. And how did the x change? Oops. From 8 to 7, or excuse me, 8 to 1, it's going down 7. So my slope, remember, is the change in y divided by the change in x. So 14 over -7, or -2. So that's my slope. So now I know the slope, an x, and a y. And if I wanted to use the point 8, -8, I could use that for the x and the y too. It's totally fine. So now I know the m, the x, and the y. I'm going to plug them in and solve for b. So let's go ahead and do that. So I know y is 6 equals m is -2, x is 1 plus b. So 6 equals -2 plus b. Add 2 to both sides, and the b is 8. So now I know the b and the m, and that's what I need to write the general form. So my final answer, any y on the line equals -2 times the associated x here, and the b is 8. Okay, so that's how we do those. So there's 3 examples for how to do those, probably one of the more difficult assignments we've had on Delta Math, so keep practicing and good things will happen.